Hey guys, welcome to Great Learning. It should come as no surprise to you that image processing is an application of data science that is seeing a lot of use around the world. Be it in terms of face recognition applications on social media or even an automated check-in for your next flight after the end of the pandemic, right? Python similarly is a programming language that will give you all of these abilities to devise really good image processing solutions in a simple yet powerful manner using the OpenCV library. Considering the rapid usage of face detection and recognition systems, it becomes key that you understand that the trend is being set and you really have to lean into these domains practically to understand them, right? That is exactly what we're going to do in this session. Excited to get started? Let's go. Before we get started, I want to introduce you to Great Learning Academy. This is a free initiative by Great Learning where you can have access to over 200 plus courses with 1000 plus hours of free content on all of the trending high demand domains absolutely free. Register now to complete the course and get your free certificate of completion as well. Check out the link in the description box of the video below for more details. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleague, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments. Coming to the agenda of this particular session, face detection with OpenCV in Python. Now it's going to be a fantastic session where we're going to be discussing a lot of different things, right? So let's get started by taking a look at the agenda first of all. At the start of the agenda, we are going to discuss two very important concepts here called as face detection and of course also called as face recognition. Now we're going to have to understand what face detection is and what face recognition is even before we go on to check how we can implement them, right? So let's understand all of these theoretically, after which, you'll be very curious to understand, so how is face recognition implemented, right? So we're going to talk a little bit about face recognition in terms of theory and in terms of telling you guys about how a deep learning system can be put into place to make an effective face recognition system, right? So we're going to understand how that works theoretically, after which we're going to take a quick introduction to this library called as OpenCV. Now if you've clicked on this video, I am sure you guys are very much excited to just put in your photos to Python and make sure that it detects your face and recognizes, right? So I'm sure you guys are also excited for that. And also once we go on to check OpenCV, right, we're going to ensure that we're going to have to take a demo where we're going to be practically understanding face detection with OpenCV. Now guys, if you're wondering about how long of a demo is this, or are we discussing a code which is maybe like 100 lines or 200 lines of code, well, to your surprise, the code is not even 10 lines of it is not even 10 lines in length. But guess what, it can, no matter what photo you throw at it, it can accurately detect your face and put a rectangle around it, right? So the demo is absolutely fantastic and you will really be surprised. In fact, you can do the demo alongside me itself and it's going to be fantastic, guys. So I hope all of you all are excited for everything that we're about to cover on this agenda, right? Perfect. Now without further ado, let us get started with understanding what face detection is. Now ladies and gentlemen, whenever we talk about this concept face detection, right, it's something that we've heard of a lot. There's a good chance we've used it also, but it almost seems like it eludes us, right? So what is it about face detection that we should know? First of all, one thing that should make you super curious about face detection is when you're learning it as, hey, so how can computers really detect objects in images, right? I mean, we as human beings are trained from our birth to look at something and know what it is, right? For example, I have a mobile phone in my hand right now. Now I can take a look at this and I can say, hey, this object is a mobile phone, right? Now I can pick up many other things such as that and say, I know it is. I know what it is, right? But then when you take a look at computers, if you just
pass an image to your computer and ask a question saying, hey, what is it in this image? It can be very simple. It can be just a simple looking apple, let's say, right? A ripe apple fruit. If you give the image, your computer will have no clue what it is unless it is trained, right? So unless you train a picture, for example, if I just show my face to my computer as an image and I say, hey, guess who this is, right? It'll have no clue that there is a human being in the picture itself, first of all. Now, this is the reason why a couple of years ago, in fact, a couple of decades ago, researchers even picked up this topic and say, hey, can we have machines understand images, right? So that is where the entire concept of face detection and face recognition came into the picture. So what is face detection? Well, face detection basically is a very simple process of, inputting an image to your computer and having your computer assess through the image, analyze through what it sees in the image, and to just put a rectangle or anything, it has to put a mark around your face, telling us that, hey, we saw this image, the computer analyzed the image, and we also to make sure that the humans understand that the computers are working fine, it will put a small rectangle box around it telling us that, hey, we detected a face in this particular image, here is the face, right? So we're going to check this out practically as well. So this is face detection. But one thing you really have to understand is that there is a huge confusion that goes on between what face detection is and what face recognition is. I'm going to clear that as we go ahead with this particular session, right? Now, as you can see on your screen, look at the second point. The second point say face detection algorithms like Viola-Jones algorithms is very popular. Now, see, with respect to face detection and face recognition, there have been so many applications around us already that just like any other domains, we have some of these shortcuts that we can use to make our lives very simple in case if we want to do any sort of face detection or face recognition, right? In that particular case, we have a fantastic algorithm, Viola-Jones algorithm. Again, it's a very complicated algorithm to explain to all of you all and to go on to show why we have to use that. But at the end of the day, we are going to keep it as simple as possible with respect to theory and with respect to the practicals as well, so that everyone who's tuning in can understand every bit of the thing we are discussing out here, right? Perfect. Now, if you have ever wondered about using this technology, right, can we have computers understand something on the image and can we use it for any other applications as well, right? Can you think of something where you put in an image to your computer and your image sort of gives you something else? The most important example that I can think of right now is one that I've used practically, right? So when you usually away from India or when you're traveling abroad, many countries will have their native signs, right? For example, if you're in Japan, all the boards are shown in Japanese. So if I click a picture of a board which is written in Japanese and I just upload it to Google Translate or Google Lens, it will immediately, right, convert whatever is written in Japanese, use the same font, put it in English and show it to me right then and there while I have the camera open. Right now, it is not face detection, but you're trying to detect something on the screen, analyze it, assess it, and even change it in real time to give you an output, right? So Google Lens and Google Translate are absolutely fantastic examples of how you can recognize something in an image and add value to it, right? Apart from just using your face detection or face recognition systems out there. Now, in fact, a fantastic way of face detection and recognition both applies when we have to open up our mobile phones to unlock the screens, right? Now, most of the mobile phones that we have today usually will give you a feature where you can unlock the mobile phone just by presenting your face to it so that it knows who the owner is, right? Now, in fact, my phone does that. I've been using this for years and years, right? So you can probably see here, right? Give me 1 second. Let me just open up my phone. Oh yeah, now I cannot open up my phone there because it will just tell me, right? If you can take a look at this, what I have here, right? The tiny thing that just came up and went back, that's the camera which was trying to detect my face. It says, hey, no face is detected because my face was not open, right? You can see that the phone is still locked. But then, of course, all of you all have done this, I'm very sure. Now that I just looked at it, guess what? My phone is unlocked, right? See, the phone is unlocked. Now, that's the most simple thing. Here, guess what? Face detection is being used. and face recognition is also being used, right? But then we'll get to the recognition part. We're still in the face detection part. What you really need to understand here is, even before you go on to perform anything else with respect to any face related technology, right? Detection, be it recognition, or you're going to use your face to change something, the concept of deep fakes, if you guys have heard, right? So anything with respect to having a face and changing it, modifying it, doing something, always starts with face detection. You really have to detect a face in the image to do something about it, right? All the concepts of anything related to face technology depends on this, and this is a very important point that I wanted to bring to your attention, so that this kind of a build up that we are having for face detection, you're supposed to be very clear at all the steps, because face detection is exactly the demo that we're going to take a look at, and having a simple yet powerful demo will add so much value to your learning at this moment of time. Right? Perfect. Now that we have taken a quick look at what face detection can be, let's take a look at what face recognition is. Right now, you guys watching the video, can you quickly pause the video, head to the comment section, and just put down in the comments saying what you think is the difference between face recognition and face detection. Right? Of course, I'm going to give you all the answers, but I just want to make sure that you guys are giving me your opinions as well. Right? So this is mostly like a conversation. You guys watch the video. If you have any questions, any comments at any moment of time, you guys head to the comment section, you put your comments down, and I will be more than happy to reply to all of your comments in case if you have any sort of doubts. Right? Perfect. Now, I hope that you guys took a second to pause this video and put down the difference between recognition and detection. In fact, the difference is very simple. Before we get to that, let's take a look at what face recognition itself is, right? In any sort of face related technology that I've mentioned, even though I said that face detection has to be the first step all the time, you really have to understand that it is the first step to what, right? 99% of the time, face detection is usually the first step to attain face recognition, right? Face recognition, again, is one of the most popular applications that we have in the entire world of, how we can go on to use computer vision in itself. We're going to discuss about all of these in the next couple of points, right? Face detection is basically how you detect how the computer understands what is present in the image and identifying a face that's present. But face recognition is very different. Face recognition involves not only just detecting a face on the image, but also recognizing who the person is, right? So you really have to think about it. It's two different things. One thing you really have to know about recognition, which is very different from detection, is that for face recognition, you are going to require deep learning, because it is very complex to teach the computer of what my face, for example, looks like, so that when I give it another picture of me, or maybe I have hundreds of photos of me, right? So if I just start pushing it and asking the computer saying, who is this, who's this, who's this, once it gets trained and it understands all the features, right? Like, for example, what my eyes look like, my face shape, my nose, my ears. So that is how this technology even works to get started with. Everything is broken down into features, right? So you can have edges, vectors, vertices, where your entire face is actually mapped using mathematics. All the concepts of statistics and mathematics come into picture, and we're going to apply all of them where it's going to understand who the person is, right? That's the exciting part of face recognition. But then to get to that, things can get really, really complex, right? So to make sure to get you guys started towards face recognition, our goal is to make sure that you guys can first of all do the first step. What's the first step? Face detection, right? That's going to demo we're going to talk about. Now, you have to understand that face recognition is used in hundreds of applications around us, right? So if I say it's used in hundreds and thousands of applications, are everyone clicking pictures and just, uploading pictures to their computers all the time? Well, not really. You can do face recognition, you can achieve face recognition by doing multiple different things. The first thing that you really have to think about when we talk about face recognition is either two or three things, right? First of all, do we always have to use images which are already ready, as in images which have already been clicked, right? Not really. Of course, one way of how you can achieve face recognition is by using images which are already clicked and present in your gallery. The second thing is you can open up your camera right then and there, click a picture, upload it, right? So you're doing both things. So hence I just thought I'll just mention it in the first point. Look at the second point. It says live webcam feed. Now, live webcam feed is very interesting, and I am very sure you guys have seen this, right? So, as and when you usually open up a webcam or you're performing some sort of, there was this very popular application which got super famous in the COVID-19 era that we're living, is a mask detector, right? If you've taken a look at a mask detector, it basically looks at an image, finds a person's face, and it reports it live, saying if this person is wearing a mask or not, all from webcam feeds. And that is just one application. Another application you can think about is, in fact, you know what, when we get to the application section, we're going to talk a lot about this. But yes, you can have a webcam. In fact, I'm recording this using a camera itself. Right now, you can have a webcam, and in fact, I can send exactly this video to my computer if I have a face recognition system ready to ask it, saying, hey, who is this, right? So after training, there's a good chance it can pick up my face and give me a probability saying, hey, I think 85-90% probability this is Anirudh. Right now, that is the absolute fun part of working with face recognition. And the third thing, of course, guys, it should really not come as a surprise to you, right? Recorded videos, of course. If you can give it images, if you can give it live images, if you're giving it a webcam feed, you're giving it a video, there's a good chance you can also give it a recorded video, right? So this really shouldn't surprise you. And these three are not the only ways of how it's done, right? A live feed is exactly what I used to unlock my mobile phone. And static image is exactly what Facebook uses when it recognizes you and it automatically tags your friends. But whenever we're trying to monitor traffic or whenever we're doing those mask related applications, that is when you're either using a live webcam feed via video or you're already using a recorded video from the past, right? So this is something you guys really need to know. But then, as I mentioned, right, you will have a question, or you had a question at the start of the session, I'm sure, saying, is face recognition any different from face detection? The answer is absolutely yes. Face recognition and face detection are two very different ball games, even though they seem very similar, right? Look on your left. I have an example that shows face detection, right? Now here, with respect to face detection, you can see all these lines that are plotted across the face of this person, right? This is how your computer understands that, hey, there is a face in the image and this is what a face looks like. And as soon as it does this, it realizes that, hey, I just found a face. So it just puts a mark around the face. In this, you can see that there is a rectangular border that is going on, right? So that is face detection. Now take a look at your right side. Right side, we're talking about face recognition. Why? It just doesn't say, hey, I detected a face. It says, hey, I detected a face and I also know who this person is. This person's name is Kathy. Right? How fantastic is that? On the right, you're recognizing the person in the image, which again is a very different thing to just seeing a face and saying, hey, there's a face there. Right? Understand this. This is the very simple difference. But then take a look at the recognition side of things. To get to this point where your phone says, hey, I recognize the person, you have to detect that there is a face and map it, match it, and find something from the result of your learning to bring it there and say that this person is Anirudh, this person is Kathy, or whoever it is, right? This is something where, the deep learning aspect comes into the picture. So I hope we are very clear at this moment of time of our understanding of, how one can go on to take a look at recognition and how one can go on to split and separate face detection from recognition. Detection is used for recognition as well, but that doesn't mean detection is recognition, right? Now, I understand detection, recognition, we're talking about it so many times, it can get a little confusing. That's the reason why we really have slowed down and you can see images on your screen so that you guys are not confused, right? Perfect. Now, we will get into a very fun discussion when we're talking about the applications of face recognition because, see, again, we can talk about the applications of face detection as well, but then everywhere we're talking about recognition also requires detection. That's the reason why I thought we can have this discussion to save some time and also talk about some fantastic applications, right? Perfect. The first application should come as no surprise to you. In fact, I just gave you a practical demonstration using my mobile phone, right? So you use it as a locking mechanism for your devices. Now, of course, you guys have used face recognition and, locking it with the face. It doesn't mean that if I lock it with my face, if my sibling or my friend opens it, it'll open. No. Why? Because my phone knows what my face looks like and it'll only open to mine. So the next question you might ask saying, okay, so what if you're sleeping and I just put the phone in front of your face and I still have it unlocked? No. So these modern face recognition and your phone lock systems will only work if you have your eyes open and you're looking at the camera, right? That is like a safety feature. Or else if everyone was sleeping, or if you already have a ready picture of someone sleeping, you can just show that to your camera and it would rather open, right? That's the reason why it's awarded nowadays. Usually Apple does this. They have a sonar, a radar kind of a technology into their Face ID, where it just projects a laser onto your face and it maps your face in 3 dimensions, and that is how it understands that this is an actual person and not a photo, so that you cannot cheat it via photos as well, right? In fact, yes. See, I have my eyes closed right now. I don't know if you can see my phone. I'm sure you can, but the camera is still upstairs, right? It couldn't recognize who I am. But then if I go on to just quickly look at it and then open it, there you go. Within a couple of milliseconds, the phone was ready, right? Exactly the demo out here. I'm sure you can do this on your own as well, right? Anyway, coming to the second point, it says prevention of retail crime. Now, how are we preventing crime with face recognition, right? Think about it. All these supermarkets, all these stores where there's cash being transacted, or where there's products, and you usually see in these movies where someone brings a weaponry into a retail chain and just takes away all the cash and runs away, right? But if you have a very potent CCTV system, which again records stuff in high clarity, what you can do is you can actually take a picture of what the person looks like and even their physique, and you can try to map it with other suspects or other people who might have been arrested for similar charges, and you can do a ton of different things rather than just being robbed. I mean, God forbid, let's hope no one gets robbed, but that's the thing, right? Instead of just having being in no place to actually say who the person is, why not use your computer, and why not use the entire database that the police will have to actually recognize who the person is that just robbed you, even though they might have masks on and everything, right? This has happened. Cases have been solved in the past using this. I absolutely love face recognition, guys. And then third thing is finding missing people. Yes, this is another superb application, which again I was researching on for a couple of weeks, where I was trying to find, hey, how do you find a missing person, right? So usually if there's public CCTVs, governments can have access to all of these public CCTVs, wherein they'll be running an algorithm on top of the video it sees. So for in any instant, any camera across, let's just say United States, finds a person who is maybe a suspect in a murder, or let's say even a retail crime or whatever it is, it will detect that person's face, automatically call the cops and say this person was detected in this particular city at this time, maybe at this restaurant, and we have the video feed to prove it as well, right? Look at that. We are saving crime with face recognition. Fantastic, right? Look at the fourth point here, guys. It says identify people on social media platforms. This has to be the biggest boon, at least in my opinion, whenever I have gone on to use social media, at least back in the day. Now I really don't use it a lot, but when you think about it, Facebook was super popular. It is still around, of course, it's still popular. So whenever you uploaded pictures of your vacation, you and your friends, right? Maybe you and 3 of your friends went on a vacation, you clicked hundreds of pictures, now you upload everything on Facebook to show off to the world. But what's happened, right? It will not show in all of their timelines, right? All of your friends' timelines, because they're not tagged into it. And instead of you manually sitting and tagging, Facebook will automatically find who it is. It will detect the faces. It will put a rectangle around it. It will also recognize the person. It will automatically tag the person for you, and it will also put a copy of it on their timeline. It will do everything that I just said automatically without you really having to do anything. How absolutely fantastic is that, right? Now that is again a superb application which is being which has already been subtly integrated into our life, that we think that, meh, you know what, it's there, it's working, right? But then you really have to understand that it takes a lot of complex programming. It takes a lot of complex working to even get to that point where it feels like, hi, this is a simple application. No, detection part of it is very simple, as you will see, but recognition is pretty difficult to obtain. But then again, nothing is super difficult, right? So let's also make sure that in the near future we'll have a session where we will be discussing about a demo regarding face recognition as well, right? Perfect. Now let's take a look at 4 more applications before we can quickly go on to discuss other things. right? The fifth point in discussion that I want to talk to you about is easing travel load on airports, right? Now, again, I am an avid traveler, so I keep traveling all around the world, and every time you're in an airport, looking at those long queues are absolutely disastrous, at least for me. So during this COVID time, I saw in a couple of places in India, again, guys, make sure you're not traveling unless it's absolutely necessary, right? So I'll give you an example. So when a couple of this was in 2020 when India was starting to go into lockdown, right? So if traveling around a couple of airports to make sure that there is less physical contact, a couple of airports have automatic check-ins, right? Now there's so much features there which are absolutely fantastic. You just go there, you show your face to a camera there. One, for security purposes, they will verify instantly to make sure that you're not someone who has ulterior motives inside the airport. Two, it'll also make sure that you have checked in and you're inside the airport. There was a time when you had to manually go to a check-in counter and they'll give you your this thing, boarding pass. You have to check in your luggage. Now all of that you can do it automatically these days, and all you have to do is go show your face, and maybe if you're flying an airline, the airline will immediately get a message saying this person has checked into the airport, right? So you entirely removing a manual process and automating 3-4 steps with the convenience of the customer just having to look at a camera, smile for 10 seconds and saving 35-40 minutes, right? That is an important thing that I personally have used a lot of times, and I find it super fun, and I really would want this technology to be again, the technology is complicated to implement, but since it's already done, it would be fantastic to see it everywhere around the world, right? So you guys can also enjoy it every time you guys fly. Okay, the next point talks about aiding for forensic investigations, right? Of course, whenever you have any sort of images, evidences, or any sort of these cases going on, there will always be times when there is that one piece of evidence that will solve the entire crime, right? And that is usually all those evidences usually have a picture of a face, maybe of a person, an alibi, or whatever it is. So that piece of information can be obtained from, of course, the trillions of photos we have in today's world by, again, putting certain algorithms into play, teaching them what the face of a suspect looks like, a suspect as in the suspect in discussion, and ensuring that it just hunts every image to make sure it finds these persons, right? Now, one train of thought you really should have is, hey, will that not require a lot of computing power? Of course, we're talking about governments of countries out here, right? And all the governments, if I'm sure, or almost all of them have supercomputers to their access, right? So they really can use all of these things. The third thing, which again I find absolutely fantastic, is tracking school attendance, right? There was a time when we were kids where they used to call out our names in the register, where we had to get up and say, hey, we are present, and they used to look at us and verify it manually, right? Nowadays, you can really save a lot of these processes by having a camera in schools and colleges, right? Have the camera ensure that it can see all the students' faces, right? As soon as the class starts or something like that, it can actually detect all the faces and attach the attendance automatically if the student was present there or not, with zero confusion. There is no back and forth with the faculties. There is nothing. You just go there, sit. The computer recognizes that you're attending the class. Right, done. How cool is that? But then it might be a little difficult if you have to escape classes for fest duties and for all the cultural stuff, right? Just kidding. Okay, let's take a look at the last point quickly. The last point we're talking about is identity validation at ATMs. Right now, this is very important, right? Just go to the news. Just open up a new tab right now. Hit Google. Just type in ATM fraud, or just type in someone got mugged at ATMs, right? You'll see that there is tons of people who get mugged at ATMs, or people who have been threatened with weaponry to steal cash and do a lot of hate crime there. But when you're talking about identity validation, you can solve some of these problems, right? So if I have my debit card, this can be seen as a limitation, but I would see it as something that might work, right? So only I get to withdraw money using my debit cards and credit cards. How will the ATM machine know who it is? Well, of course, it will see my debit card as soon as I insert it. It's going to open up the camera. It's going to probably just take a quick look at my face and then detect it, match it with their algorithm in the back end, or it can even have a person there, right? That's how usually technology starts. There's a person who sits there to manually verify something, and later everything is automated, right? So of course, course, we can get to that point as well. Knowing that these ATMs are monitored 24/7, the ATM can just understand that, hey, this is Anirudh withdrawing his money, let's just allow, then proceed, and only then the cash is dispensed. Else it can give you any other reason as well, right? But then, of course, if it's a medical emergency, there's a lot of headache. But that's again a technology where a space where you can explore a lot, and of course, you can do all of that using nothing but face recognition. Now, to quickly give you a theoretical idea of how face recognition actually is implemented, using deep learning, let's discuss this theoretically. Let's understand it in a simple fashion. So maybe in a couple of days or in a couple of weeks from now, we can have a session where we're going to discuss how you all can perform face recognition practically, right? But then to get to that, you have to make sure you guys are clear with this particular demo that we're going to discuss in terms of detection. But then let's come back to face recognition. See, what usually happens when you try to attack the concept of face recognition and you want to do it on your own as a learner or as a person, as a researcher, whatever it is, right? This will exactly be the train of thought that I'm about to tell you right now. The first thing whenever I try to solve any problem is I try to find the data set, right? I need the data set because I need to understand what it is that the data is telling me, what I can use from the data. And a very important thing is how I can use the data to the best of my abilities to find all the top features, use the top features, try to see if we can have machine learning, deep learning, try to see if we can automate something there or perform exploratory data analysis as well, right? So data set is the first thing for me. Now, when you're trying to think about face recognition on a worldwide scale, training a network that big is going to be super complex. It's going to take a ton of data and it's going to take a ton of computation power, correct? All of these are again accessible, right? When I say ton, I'm not talking about having 10 i9 or i7 computers glued together to work. You can do all of these things practically yourself to get started. But then I'm telling you the practicalities of teaching a network, right? Take a look at the second point. This is how we usually work with whenever we're thinking about face recognition. We use a pre-trained network. Many times, we have this data set trained by this person called Davis King, right? It's a data set of 3 million images. It has used a data set of 3 million images to learn continuously and to have a very high rate of efficiency, right? So you don't have to train another neural network. You're using a neural network that was trained by someone else, right? And there is a very fancy term, if this is machine learning, it's actually called as transfer learning, where you teach something on one data set and you just use the same learning or the knowledge to see if you can test on another data set, right? It's called transfer learning. But as we're talking about deep learning, you have to understand this. We already have a pre-trained network. That is how, all you guys, beginners and intermediate users, whenever you go on to learn these, this is what makes your life simple and give you fantastic looking results when you perform face recognition, right? But then you might have a question saying, okay, even if I showcase images to my neural network, how will it understand images? Right? It will understand images as numbers, as mathematics, as vectors, right? The output of the neural network is basically a vector that consists of usually somewhere around 128 numbers. And each of these numbers will represent like an important feature of the face. Maybe it'll talk about how blunt your nose is, how long your nose is, your eye color, how far away are your eyes from your forehead, how big is your forehead, do you have a beard, do you have a mustache? So there's a ton of features here that gets detected, right? 128 different features, in fact, where it will give you an output saying, hey, this is what is mapped to this person, and these are how much percentages of vectors that were mapped. So there is 100% or 99%, 98, 50%, 60% probability that this is the person. That is how it works in terms of data set, right? So what do you usually do once you have a data set? Once you have a data set, the first step is to perform face detection, of course, right? This should not come as any doubt to you. As I've already told you, with the detection and recognition, no matter where you're going, you really have to detect the face first. So, in an image, there can be a lot of different things. There can be a background, there can be a mountain, there can be someone who's facing backwards, there's another one looking at the camera, right? The photos endless possibilities. So the first thing that your computer really has to do is to find the exact location of where your face is, right? It sees an image, and look at this. In fact, the image on your screen right now is talking a lot about it, right? It's giving you the entire head form. It is telling where the eyes are, where the cheeks are, where the nose is, where the lips are, right? So it knows, it understands that, hey, this is the person's face. We're going to use this, and we're going to maybe take a screenshot of just that face to map it to other faces that you will have in your database, right? Step number one, that when you're talking about step number two talks about feature extraction. As I just mentioned, right, we really need a mathematical numbers from an image or a face that we've seen so that it can be used later to convert it into a number, an image to a number, where this technique, when we go on to do this, right, embedding is basically what it's called as. It's actually also known as deep metric learning. Deep metric learning basically uses a function, in this particular case, a function of an image, where we're trying to find all of these features and we're trying to extract these features. And in fact, let me go back to step number one. You can see that, right? For example, the eyes will get one feature, the left eye and the right eye. The cheeks will get another number. The nose will get a number. The lips will get a number. So you can use all of these vectors to actually map what a face looks like, the structure of a face and the underlying meaning of what it's seeing as well, right? Now, that is step number two. So I hope you're clear with step number one, which was detecting your face. Step number two was, after you detect the face, you really have to make sure you convert it into vectors so that your computer or your neural network can understand something. Now, once that was done, the next step is what? You have everything you need to input into a neural network right now. So we start training a network, right? Look at the image on your screen right now. You will see two images of Arnold Schwarzenegger and two images of the President of United States, the ex-President of United States, George Bush, right? So a neural network will output faces which might look very similar to each other. If that is the case, what is the solution then, right? Now, maybe I just asked the question saying, hey, find me faces of Arnold, and it just brought out faces of George Bush as well. What do I do in this situation? If your face is very similar, you basically perform another iteration of analysis where you dive more into the depth of the network, right? So you can have multiple hidden layers in the neural network, which will eventually get to a point where it can accurately tell that, hey, this is George Bush, this is Arnold Schwarzenegger, right? I'm just glad I picked up Arnold's name because his second name is super complex to go on to tell Schwarzenegger. Right? Cool. After step number three, we'll come to step number four, guys. Step number four talks about how you can use feature map to go on to actually understand something of what's happening around the face of a person, right? So after you train a network, it'll basically group all. It's called as classification. It's called as categorization. It's called as grouping. Everything means the same. So what your neural network does after training is that it will go on to map all these features and say, hey, look at this. These two pictures of Arnold looks very similar. So can this be one person? Yes or no? In that case, the neural network would have given an answer saying yes. That's the reason why you see both the pictures of Arnold in one section, right? And in another section, similarly, it would have taken a look at images of two images of President Bush, and it would have taken a look at it. It would have understood saying, hey, these people look like the same person. Can we combine it, right? So this is step number four. Just mapping all your features, training even harder to ensure that you can understand something. And once you start looking deeper and deeper into the face of a person, right? Now, when I'm saying a face, think about it from the neural network perspective. So when you're having a deep dive into it, there is only a certain limit where it'll work really fine, right? If I have an image, what if I continuously keep zooming into it without any stopping, right? Eventually I'll get to pixels. Each pixel makes up an image. Here also, if you think that if you just train your neural network a lot, it'll work better. Sometimes, especially for face recognition applications, your neural network can overfit as in it'll start picking up noise and useless things, which will eventually affect your model efficiency a lot, right? So it doesn't mean doing it more means you're doing it better. No, you have to be very careful of overfitting for face recognition, because people don't realize why their models are going wrong, and by the time they realize that, it'll be too late for their application, or that it'll be a very simple analysis of at the end of it saying, oh, I should have just taken a look at overfitting, right? So that's the reason why I'm giving you this kind of a pro tip that you guys can use when you are learning face recognition down the line, right? Perfect. This brings us to step number five. Step number 5, we're here after your neural network has learned, and of course, we're going to be using all the images, and we're going to be using to, we're going to be basically computing the face embedding for all the images that are there using the same network. And if you do not have embeddings, what will usually happen is, I'll give you an example here, right? So let's just say we have a network which understands what President Bush looks like. So it has some sort of a reference, it has an embedding to get started with. But then I have a picture of President Putin as well, but President Putin, the embedding of this particular person was not saved. So, what my neural network will do at this moment of time is it will not know who this person is. It knows that there is a person, it knows that there is a face, it knows that it probably looks similar to all these other people as well, right? I mean, come on, all these are human faces. There has to be some percent of similarity. But can it confidently say that this is this person? No. In this case, it will not, because if your face embedding is not at all computed, it will not even know what it has to find or hunt in the face of this particular example to know what the person looks like, right? It's me telling you, hey, perform face recognition, but have a blind on your eye, right? Maybe wrap a cloth on your face and do it. It's not possible if I cannot see, right? Similarly, your deep learning network cannot learn unless it understands what it is, right? The same analogy of having something on your face covered to you not seeing it practically. So perfect, guys. These are the 5 most important steps that you really have to keep in mind when you guys go on to learn about how you'll be implementing deep learning practically. Now, along these 5 steps that we discussed, I not only told you what these steps mean or the order of how these steps work, but I also ensured to give you a couple of tips along the line in case if you guys are training a model on your own, right? So I hope for all the people who are practically coding your own face recognition model here, that you can use some of the tips mentioned in all these steps to actually have another footing or to have another approach to see if you can do something better as well, right? So that you can use as another win point. Now, once we've understood how we can go on to do these face detection concepts and face recognition also, once you understand how the networks do it, the next thing you'll want to start doing is understand stuff practically, right? As I told you before, we get to the practical aspect of it. The next section that we're going to take a look at is the practical aspect, but then we're going to be using a library called as the OpenCV library. So it always adds a lot of value for us to first understand what OpenCV is, right? Only then we can think about how best we can go on to use the library. Fantastic. Now, OpenCV, as you can see, the C and the V are capitalized, right? So CV basically stands for computer vision. Computer vision is basically giving the computer a bit of intelligence so that it understands what it sees in terms of visualization, and it uses computer software to bridge the gap that exists between softwares and visualization, and eventually let it understand the image, right? Now, what my computer is doing right now is basically recording everything that I'm saying, right? It is just using a software to record. But is it performing any sort of real-time analysis to check whose face it is that's talking right now? No. So this is where computer software is being used, where it knows how to perform visualization. There is a gap, right? This gap needs to be bridged between software and visualization, and this is where you as a person who works on OpenCV will come into the picture, because having your computer understand images is one thing, but the other thing is to know that the number of applications, we discussed 8 applications, but if you give me probably half an hour worth of time more, what we can talk about is maybe another 10-15 very different applications which you may or may not have heard of, right? And again, that's 10 or 15 in a list of thousands. This is something you have to keep in your mind, right? Perfect. So, making a computer understand not just images. So whenever it's training to hunt for faces, there's a good chance it can also learn about something else. All the visualization stuff it sees in the surroundings, right? Maybe you want to do a plant detector, right? Militaries use these detection software all the time. How do you think they try to find the stuff, using the satellites, right? They have huge cameras on these satellites, and these satellites have the capability to zoom in on a particular target, to zoom in on a building, to zoom in on a forest or anything like that, right? It can automatically do it without a human manually moving the satellite around the earth to zoom in and zoom out and all that, because it understands there is a process to do it. There are standard operating procedures which will at a couple of clicks of the mouse button, I am sure that you can move a satellite around and have it focus and find a forest, zoom in on a part of the forest, even tell you temperature, right? See, I'm getting carried away. Again, you can find a ton of applications is what I want to say, right? Of course, when you're taking a look at the example, determining a fruit based on the color, shape, and size as well. This is something that you can do with respect to OpenCV. Make sure you train the neural network model multiple times with respect to multiple fruits of having multiple colors, multiple shapes. If you talk about an apple can be in two colors, right? One is green when it's not yet ripe, and once it ripens, it becomes reddish color, right? And there are multiple tones of that red color as well. So you have to teach your machine what these colors look like, shapes look like, and it's not like two apples will look exactly the same shape, right? When you think about it, apart from the iPhones or anything from Apple, the brand, the company, right? So this is OpenCV, guys. Computer vision is going to be a fantastic library. In fact, it is the world's most popular library that's used for face recognition. One reason why is that it is open source. You really don't have to pay anyone to use all the powerful capabilities of OpenCV. If you are confused about saying, hey, what are these powerful capabilities? I'll just show you the powerful capabilities when we go on to detect faces in our images with less than 10 lines of code, right? Look at the second thing. The second point is the reason why I mainly believe it gained popularity. It will work with all the programming languages we have, such as R, such as Python, and more. Now, Python is the top programming language in today's world, so it should really not come as a surprise to you when I say that, hey, it's used by Python or it works really well with Python. Of course, Python works fantastically well. OpenCV is a library on its own that is super, super powerful, super efficient. So when you bring these two together, of course, it's going to lead to a ton of applications, right? That's the thing. That's what I've been trying to convey throughout this entire session now. The third thing, again, think about it. This is also what makes OpenCV popular, is that it will work on multiple operating systems, be it Microsoft Windows, be it Linux, be it the ton of flavors of Linux that we have in today's world, and even Mac OS, right? Usually it is very limited if you say that, hey, I have a library that will work, but it will only work in Windows and not anywhere else. Well, one train of thought can say that, hey, okay, never mind, there's a lot of people who use Microsoft Windows. But the other train of thought is you're trying to not reach an audience worth millions just because of the fact that they don't have your platform, right? So again, OpenCV gives you a ton of advantages here. It'll work with Python, it'll work with R, it's absolutely free, it works with Windows, it works with Linux, it works with Mac OS, it is super efficient, it is super popular, it has already, in fact, while I'm even speaking, OpenCV is somewhere in the world right now being used by tons of companies out there where they're trying to do something right now using this library, right? That's how popular OpenCV is. So now when we go on to talk about how OpenCV is even used, right, there's usually 4 simple steps of how one can go on to think about using OpenCV. I'll talk about all the 4 steps, but I'll give you a quick brief about it instead of giving you a lot of information about this because we're going to check this out practically, right? Okay, so the first thing that we're going to have to talk about with OpenCV is you have to gather all the data. Now, if I have to perform face detection, let's talk about our demo itself, face detection. Now, if I have to go on to detect a face, what do I need? I'm going to need a couple of images which may or may not have faces in them. The second thing is I need Python to understand what the image looks like. That is where OpenCV comes into the picture, right? So first step we are done. We gathered a couple of, I just went through my mobile, I downloaded 3 or 4 pictures of myself, I put it on my computer and I have my data ready. The next thing I should do is data processing, right? In some cases, what might happen is that even though your image is really good, there is a good chance 1 or 2 images among thousands can be confusing your machine learning algorithm to a very bad extent. It happens, and this is the one step before the model overfits. As in, overfitting is the worst case scenario where it's just giving you random numbers because it doesn't know what it's looking at. One step before overfitting is when it starts to look at data which it may or may not understand. It's only finding noise, right? It is inching into the world of overfitting. To avoid that, we require data processing. We have to clean it up, either delete it, move it, manipulate it, do something to the image so that it really doesn't hurt or confuse confuse your machine learning algorithms or anything like that, right? And of course, the next thing is, once you have the data, once it's pre-processed and ready to be trained by a model, OpenCV, you really don't have to think about the last two steps. It doesn't mean that you have to compulsorily use a model that has been trained to go on to perform all of this. In fact, you can have your own models, you can train your own models and use it regardless, right? But 99% of the time, let me tell you this, even in commercial and enterprise grade applications, people start using pre-trained networks, because training a neural network to maybe, let's just say, world population, right? If you have to train an image and give it at least two pictures of one person, right? Maybe from the side and from the front, you're going to have over like what, 10, 12, 14 billion images. Now, to train a neural network to look at 14 billion images, it's going to take a ton of time. It's going to take a ton of processing power. It's going to take a ton of space and everything else, right? So you really have to keep that in mind. Most of the time we use pre-trained stuff. There are some times where you have to create your own network, but then those are the rare times that you will have to look towards as well. Perfect. Now, why do I say look towards? Is mostly because of the time where if ever you get into an interview and they want to make sure that you can do a similar thing without using the library or without using the functionality of a library, you must have the capability to do it, right? Okay. The last step that we're going to talk about is model evaluation. Model evaluation is very simple. You try to assess what your deep learning model, your neural network, your machine learning model has learned by giving it a test. It's a very simple concept, right? For all the people who might not know what machine learning or deep learning is at this moment of time, I'm going to explain all these steps quickly, right? So it's basically like you going to your college, buying a textbook, reading everything in the textbook, and then keeping the textbook away. And then your teacher will give you an examination. So you go and write your examination. Now, how will your teacher evaluate you? Will he or she evaluate you based on the textbook or based on what you wrote using the learning that you made from the textbook, right? Of course, they're going to evaluate your answer paper. They're not going to sit and evaluate the textbook. That's the reason to make sure that when I say evaluation, you have to provide the testing data to evaluate a model rather than having the training data, right? Now, while the example that I just told you, if I am still having a textbook right next to me when I'm writing my examination, I can literally copy word to word everything and I can find 100% accuracy. That's not what we want. We're not trying to cheat the system. We're trying to beat the system here, right? So that's the thing. To beat the system, again, you really have to understand of how you can train your model using data. 99% that's pre-trained, and how you can use it. Most of these applications will have the common start of detecting the face, recognizing it, or maybe trying to change that. Now, for the people who might want to understand, okay, so we know detection, we know recognition. What is the next thing that you can do to change something around in a face-based technology? Look at the concept called as deep fakes. DEEPFAKES. Fake as in fake, right? So look at that. There you'll see that you can do stuff real time to a particular video where it's absolutely fantastic. It's a very dangerous aspect of technology as well, again, right? You can just have anyone's face and you can make them say stuff which they might have never said because it's someone else doing it and it's just an animated version of the face, but it doesn't look like an animation because their actual face is being manipulated. And this is not being done like those 1980s or 1990s cartoons that we see, but this is being done by, it is very convincing, right? You can look at a deep fake video and you will never know if the person actually did it or not unless you use certain tools and try to assess to see if it was deep fake or not, right? Anyway, coming back, now is the most fantastic part of our particular session is we're going to actually dive right into Python and we're going to take a look at this particular demo that I have planned for you guys where we're going to be performing face detection with OpenCV, right? But then before we get to that, what is the most important thing that I told you all, right? The first most important thing that all of you all should really be concerned with is the data at hand, right? Now, let me quickly go on to my desktop. I'll open face detection files. I'll actually open up two files that I want to use to perform face detection, right? Again, both of these are my faces itself, but then both are very different. So I want to see if my this thing program can actually go on to solve and find and detect a face here, right? Let me open both the images, in fact, for you guys. Right now, these are my pictures itself. These are pictures of me where one you can see that I have a straight pose and this sort of looks like me in short hair. I mean, of course, it's me in short hair. And then I wanted to see if this particular model can also find a face if it is sideways, right? Now, looking at a face head on, you can probably tell what a face looks like, but maybe my computer might not understand what a face looks like, especially if it's at the side, and if it's especially near an ocean and I have a specs on, I have a huge beard on, and I have a ton of hair, right? So everything in the image that you see on your right is meant to confuse that particular, confuse the computer itself, confuse its learning to see if it can be confused or not. But of course, on the left hand side, it's just my face, right? Both have my faces, but let's just see how we can go on to use these two faces to see if we can have some sort of result that we can go on to use, right? Perfect. Now, what I'll do is I'm going to quickly open up Google Chrome here, and I'm going to open up Google Colab. Right now, Google Colab is basically it's a Jupyter notebook that's hosted on the Google Cloud platform. To get to Google Colab, all you have to do is you have to go to collab.research.google.com. Let me show that again here, right? collab.research.google.com, or you just go to Google and type Colab, COLAB, and that will be the first result that these guys will show you, because it's their own search engine from Google and it's their own product as well, right? Okay, now what I'm going to do is I'm going to sign into my email ID. Alright guys, so I just logged into my particular account, my Google account. Basically, if you have a Gmail account or any other Google account, you can actually sign in for free. Google Colab is a free tool to use. So the most simple thing that you guys can do is just start entering your pieces of code and start running it. That's it. You don't have to install Python, you don't have to configure Python, you don't have to break your head about why something is not working, how do you program the path, how do you work with the environmental variable, how do you do this, how do you do that. Absolutely no confusion, right? Just start typing your code, hit enter, and if your code is syntactically correct with respect to Python, it will work for free, right? Now, this is not using the computing power of my laptop right now. It's going to be using the computing power of all the servers it has, right? Huge rugged servers Google has for their Google Cloud Computing platform, right? GCP. So this is basically a Jupyter notebook hosted on the Google Cloud platform itself, right? Now, anyway, guys, coming to our demo, we're going to be doing face detection with Python, and we're going to be using the OpenCV library here. Now, understand what we're doing. We're trying to detect a face, right? So to go on to do that, basically, if you are thinking about how many lines of code are required, 100 lines of code is required, as I just mentioned at the start of the session, I'm going to be doing this on how many lines? 1, 2, 3, 4, 5, 6, 7, 8 lines. In fact, you can actually do it in 6 lines of code, right? Think about it, 6 lines of code and you're doing face detection. How simple can Python get? How simple can OpenCV get? And how you can just understand that if you have a face recognition project, right? 8 lines of code and you're done with face detection. So rest of the time you can actually think about how you can work on building the neural network and all of that for your recognition applications, right? Now, what I'll do, ladies and gentlemen, is I'll zoom in a little so that all of you all, right? I know a lot of you, watch these videos on your mobile phone. So I just want to make sure that you all can see the code. And in fact, you can do it alongside me as well, right, guys? Let's get started. The first thing is I have to connect to the runtime here. I just connected. Let me go on to the runtime and see what type of runtime we have. It has to be a GPU based hardware accelerator because we're going to be using images a lot, right? GPU as in graphical processing unit. It's also called as a graphic card. Now, it's not using my graphic card in the laptop. It just assigned me a virtual graphic card which is present in a server sitting anywhere across the globe in any of Google's data centers, right? So I'm using their hardware. I'm using everything from their side for computation purposes. And all I'm doing from my side is entering the Python code, hitting enter. That is it, right? Cool. Now, what is step number 1, ladies and gentlemen, when we're working with solving any problem? Step number 1 is to make sure you guys will always import every single library that you are going to require, right? So let me just click this button, and as soon as I hit that play, and as soon as it stops rotating, you can see that I've imported the OpenCV library. If you had to manually do this, you have to download it, you have to pip install it or install it via Anaconda, you have to configure it. Sometimes it works, sometimes it doesn't work, right? I am sure you've been in that situation. But this time, all I did is hit that button and it's ready. Now, I told you about how most of the time we'll be using a pre-trained classifier from OpenCV to go on to detect faces for us, right? Or we'll have to just go through the entire step of having millions of images and training a network based on that. Look at this. One line of code, basically all we're trying to do is open an XML file which consists of it. It's called as the cascade. So when I go on to talk about how we'll have to go on to use this particular cascade, the first thing we'll have to do, ladies and gentlemen, is to upload the file, right? Or it's going to give us an error. So what I'm going to do, I'm going to go to my desktop, and I have the files related for this, and I have this particular XML file called as face detector. Right now I'm going to open it, and I'm going to upload it to the Google Cloud Platform. Now it knows where the particular trained file is, right? So as you can see, it's rotating here on the left, yellow color, and as soon as it completes rotating, it's basically trying to upload it and have it ready for us to use. And can you see this file here, face underscore detector XML? Now our file is ready. So what do I do is, as soon as I go on to run this, now there is this pre-trained network, all the data from our trained network, which is already pre-trained and ready. So we have loaded the cascade. Now the next thing we need to go on to do is give it an input image, right? It needs an image of a face to see if it can detect anything. All I'm trying to do is use this method called as imread, and I'm just giving it the name of the file. Now the name of the file that I wanted to understand is test1.jpg. Now what I'm going to do, I'm going to upload it. Right now, guys, just to save time, I'm going to upload both test1 and test2. Okay, so as you can see, I'm uploading both the files. Otherwise I just have to do it again. So now you can see that test1 is uploaded, test2 is uploaded. In fact, let me click on test1. Let me double click on it. As soon as I double click on it, on the right side you can see what this image is. Right, this is me, this is my face. Fantastic. So I have the correct image. So let me just close all of these things. So guys, the next step after I've actually uploaded an image, as you just saw, is to make sure that we can perform face detection, right? Now, face detection is a fantastic thing, especially with OpenCV. You can see this function called as detect multiscale, right? So this one function, this literally one function is going to be used by us to do the entire recognition aspect of things, to find where the face is, right? This is what is used. Now, as soon as I go on to click on this, now it has actually found out where my face is on the image. Now, how do I know if it understands this? How do I evaluate if it has detected my face correctly or not? Right? That is when I'm going to have to actually draw a little rectangle on my face so that I understand, hey, my computer knows where my image is or where my face in the image is. Right? Now, as soon as I go on to click on this, all we are trying to do is we're trying to create a rectangle on our own image. So basically, we're trying to copy an image, have the image ready, in that find the x and y coordinates, right? It's a two-dimensional image. It has x-axis and y-axis. Then I'm just going to try to add these values w and h to basically go on to just find where my face is, center it on my face, and put a small rectangle there. Right now, as soon as I click on this, the rectangle is drawn on my face. Now, what's the next thing that I have to do? So after it has basically detected my face, right, the next thing that we're going to have to take a look at is seeing the result. So what I'm going to try to do is, again, one line of code. It says the photo is successfully exported. But where is the photo? Let me click on this, and it would have created one more file for us. It's called as face underscore detected.png, right? You can see that this is the output file. So this right now should be the output file, right? Let me right click on it. Let me hit download. And as soon as I click on download and I open it, you will be surprised to see that our face detection worked with 8 lines of code, right? Look at this. It found out in this image where my face is. It zeroed in on my face, and it has put a blue rectangle on my face. Now, this is a very straightforward image where I'm looking into the camera, where it looks like a guy. Now what I'm going to do is I'm going to want to confuse this particular model here. I'm going to change it to test2.jpg. Do you remember test2.jpg, ladies and gentlemen, where we actually go on to, have a picture of my face with really long hair, and it's a sideways pose, right? So this is again me with long hair. Now I'm going to see if it detects my face here or not, if it knows what the face looks like sideways. Of course, it's been trained with multiple different millions and millions of images, so I'm sure it'll do it. So what I'm going to do is I'm going to start executing all these pieces of code again. I just changed test1 to test2. I'm going to run this piece of code, and as soon as I run this, it has detected my face. It has already seen it in the image, or it might not have, or it might have detected it wrong. We're not considering all those exceptional cases here. What is the next thing that we have to do? Draw a rectangle on the face. Once we draw a rectangle on the face, I'm going to see if it's correct or not. I'm going to export it. Now again, it might export it with the same name, or of course I can change the name here as well. Let me download it again, and this time of course it's going to be the latest one. It's going to be test2. Right now, as soon as I open this, it might have detected. Yes, you can look at that, right? Even with the side post, even with shades on, a lot of beard, a lot of mustache, ton of hair, and a very confusing angle on the picture, this algorithm understood, this pre-trained network was intelligent enough to say, hey, here's your image. And what we're doing, all of these, ladies and gentlemen, with 8 lines of code, and I'm very confident that I can convert all the 8 lines of code, maybe bring it down to 5 or 6, right? Now, this is the entire magic of Python. This is the entire magic of how one would go on to use Python with respect to OpenCV and with respect to face detection, right? Now you can definitely write a lot of lines of code going ahead from here. Once your model has already detected a face, you can use the detection, make your model take a screenshot of it, send that into a neural network, convert it into vector embeddings. Once it understands who the person is, you can perform classification, you can perform, you can give a probability of an output saying, hey, right? So let me actually show you this. Now, let me go to downloads here. Let me go to downloads. Let me open up the first image that it gave me, right? This one. Now, as soon as I look at this, it can take a screenshot of my particular face. It can detect all the features of it, and it can use this, in fact, to learn for maybe other faces that I might give of my own, right? Now, if I just use one picture to train my model and say, hey, can you please tell me who the guy in the side pose is? There's a good chance it cannot do that. If I've just trained it on one image, but if I've trained it on hundreds of images, it can tell me that, hey, a face has been detected, right? Now, if this was a face recognition system, it would say face detected, Anirudh Rao, right? It's not saying that because we've just done face detection here, but then this is the first step to get to recognition, right? Cool. So this was the simple demo that I wanted to show all of you all. And as I told you, it's very simple, right? It's a couple of lines of code, and you guys can do it alongside me as well. The Cascade file is again available on the internet. What you can try to do is you can take a look at any images of your own, right? I'm sure you will have pictures of yourself. Upload it, try to see if it can find your face or not. Head to the comment section and let me know about the result, right? So guys, with that, we have come to the end of this particular session. We started the session out by first of all understanding what face detection is and face recognition is in its most simplest terms. Once we were really clear with detection and recognition, we understood the differences, we understood that they're not the same, we understood that detection is also required for recognition, right? And then theoretically we understood how one would go on to perform face recognition by using a very complex deep learning algorithm. We covered all that aspect of theory, later which we took a look at some of the most interesting applications, right? Of course, we took a look at all the applications, we understood them, we realized that we can talk about more applications as well, but at the end of it, we made sure to take a quick introduction to understand OpenCV. And I told you, right, OpenCV is this, I kept saying that it's a super powerful library. Now, why did I say that? You literally saw that I used 6 or 7 lines of code and we could just perform face detection as easy as it is, right? Now, I just inputted one particular image there. You can input hundreds of images of your own and go mad, right? It's a world where you can do anything on your own. So make sure you guys are putting in your images, working on it, and I hope that everything we have covered in this particular video is clear to everyone, right? Superb. Thank you so much for watching. My name is Anirudh Rao, and I'll see you on the next one.
I want to introduce you to Great Learning Academy. This is a free initiative by Great Learning where you can have access to over 200 plus courses with 1000 plus hours of free content on all of the trending high demand domains, absolutely free. Register now to complete the course and get your free certificate of completion as well. Check out the link in the description box of the video below for more details. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleagues, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments.